Hello everyone. In this activity we'll be learning the difference between permutations and combinations. Given 4 distinct letters A, B, C, D, we need to form a code of 4 distinct letters. How many codes can we have? For the first letter, there are 4 out of the 4 possibilities to have the first letter. Now, because we want 4 distinct letters, it means that repetition is not allowed. If I chose A for the first, then I cannot have A again in the second part. So here I have 4. For the second one, I'm left with 3 possibilities. So here we have 3. For the next one, I have 2 possibilities. And for the last one, I have 1 possibility. And therefore, the answer will be 4 times 3 times 2 times 1. We multiply the possible outcomes. The number 4 times 3 times 2 times 1 will be noted by 4 factorial. We read it 4 factorial. In this part, we are permuting 4 letters out of 4 with no repetition. Just a remark on the factorial. N factorial means it is to multiply the n by n minus 1, n minus 2, n minus 3 till reaching 3 to 1. So it's to multiply n by all natural numbers that are less than n. In part B, we are given 5 distinct letters A, B, C, D, and E, for example, and we need to form a code of 3 distinct letters. Here in this part, we are given 5 letters and we want to have a code of 3 letters. With having distinct letters, it means that also repetition is not allowed. Okay, let's think about this part. Is the code ABC the same as the code ACB or as CAB? No, for sure they are not the same codes. Therefore, these codes are different. Then in this part, order is important. Order is to be taken into consideration. In the first, A is the first. However, here A is the second. So order is important. Then, as we said, we want to choose 3 out of the 5. So in the first place, I have 5 possibilities. In the second, I have 4. And in the third, I have 3. So in this part, it is to permute 3 letters out of 5. We note this by 5p3. I am permuting 3 out of 5. To find the answer using the calculator, class Wiz, we do 5 shift times 3 equal, and we get 60. In part C, in 7CPP there are 14 students. Joy, Alex, and Zayan are elected as a committee representing the class. We want to have among these students a president, a vice president, and a treasurer. In how many ways can this be done? If you want, we can list the possibilities. Because we have here only 3 students, I can try and play it as a game. And here are the outcomes. Joy president, Alex vice president, and Zayan treasurer. Joy president and shifting between Zayan and Alex. I choose Alex as president and shift between Joy and Zayan as president, vice president, and treasurer, and the same for the last part, and I can count them. But there is always a way to find a solution without listing. I can say, among these 3, how many can be president? For sure 3. The 3 of them can be president. But once the president is chosen, now I have 2 possibilities for vice president, and I'm left with 1 student as a treasurer. and therefore the answer is 3 times 2 times 1. In this part, the answer is also 3 factorial because I'm having 3 times all the numbers less than 3 till reaching 1. In this part, we call it, I'm permuting 3 out of 3, so we can also use the calculator and do 3p3 as we did before. 3 shift times 3 equal, and we will have the answer. Now we want to have a president, vice president, and a treasurer out of the 14 students in the 7 CPP. So out of the 14 students, I have 14 possibilities to have a president, 13 possibilities to have a vice president, and 12 possibilities to have a treasurer. Because also repetition is not allowed. So I am permuting 3 out of the 14. And the answer is 2184 committee. Also, we can use the calculator doing 14 shift times 3. This is Casio ClassWiz, and we get the answer. Now, out of the 14 students of 7 CPP, a group of 3 students needs to meet the director. So, out of the 14, I need to have a group of 3 students to meet the director. How many groups can we have? If we think about a group, for example, of 3, let's take Zayan, Alex, and Joy. If I take the group Zayan, Alex, and Joy, or Alex, Zayan, and Joy, am I having the same group? Yes, it's still the same group. I didn't change anything. In this example, order of permutation is not taken into consideration, so order is not important. And in this case, I cannot use the same properties as I used before, because order is not important anymore. So, the permutation by itself is not a way to find the answer. I'm not permuting 3 out of 14, so this is completely wrong. And in this case, mathematicians have to find something other than permutation in order to find the answer. So another tool of counting where order is not important is needed. What is this tool? The new tool is combination. So in this case, I am combining 3 out of 14. I am choosing 3 out of 14. So the letter C is for combination, or sometimes you can say it is for choosing from C. So I am choosing 3 out of 14, or I am combining 3 out of 14. Now how to find the answer using the calculator? To use the calculator, we do 14 shift division 3, and we get 364. What is the combination? The combination of R out of M is to have M factorial divided by M minus R factorial times R factorial. This is the formula. Sometimes we have to use the formula, sometimes we just use the calculator and get the answer. So to use the formula of combining 3 out of 14, we take 14 factorial over 14 minus 3 factorial times 3 factorial. You know 14 factorial is 14 times all the preceding number till 1. And then we have 11 factorial times 3 factorial. If you take 14 times 13 times 12, and then all the remaining is 11 factorial, so I can simplify 11 factorial with 11 factorial and have the answer is 14 times 13 times 12 divided by 6, which is 364. Another notation for combination other than MCR, it can be the capital C, M at the top and R down, or also sometimes parentheses, M at the top and R down. The 3 of them means that I am combining R out of M. Thank you.